Hello students, in this class I am going to explain you about equilibrium state and equilibrium constants like Kc and Kp. It is from chemical equilibrium chapter. So now we will discuss what is equilibrium state. See, in a chemical reaction, say for example, reactants are converted into products, no? A plus B are the reactants which are reacting together to form products such as C plus D. These two are reactants and these two are products. So it is the forward reaction, it is the backward reaction. In a forward reaction, reactants are converted into products, but in a backward reaction, products are converted into reactants. See, in this reaction, equilibrium state is the state at which rate of forward reaction is equals to the rate of backward reaction. If both the rates are equal, then that reaction, that state is said to be equilibrium state, or also called as dynamic equilibrium. So we have some characters for equilibrium state. See, what are the characteristics of equilibrium state are? At equilibrium state, rate of forward reaction is equals to the rate of backward reaction. Equilibrium state can exist only in closed vessels. Only in closed vessels. Equilibrium state can exist in closed vessels. Equilibrium reactions or equilibrium state can be possible in reversible reactions. It is possible in reversible reactions. At equilibrium state, concentration of reactants and concentration of products remains constant. Remains constant. See, at equilibrium state, change in Gibbs free energy is 0. Change in Gibbs free energy is 0. And at equilibrium state is influenced by concentration, pressure and temperature. Equilibrium state is influenced by temperature, pressure, concentration and addition of noble gas. Addition of noble gas. So these are the main characteristics of equilibrium state. At equilibrium state, rate of forward reaction is equals to rate of backward reaction. Equilibrium state can be established only in closed vessels. Equilibrium state is possible in reversible reactions. At equilibrium state, concentration of reactants and concentration of products remains the same. At equilibrium state, Gibbs energy change also 0. And equilibrium state is influenced by temperature, pressure and concentration and addition of noble gases. And what is the role of catalyst on equilibrium state? Catalyst has no effect on equilibrium state. Catalyst has no effect on equilibrium state, but what is the main role of catalyst is, catalyst enhances the rate of forward reaction and rate of backward reaction with the same extent. Catalyst is trying to establish the equilibrium for a reaction quickly. After formation of equilibrium state, there is no role of catalyst, there is no effect or influence of catalyst on equilibrium state. So these are the characteristics of equilibrium state. Now we are going to understand about equilibrium constant. See, for the same reaction, equilibrium constants, how would we write? See, we know law of mass action. The same thing came in chemical kinetics also in the case of rate. The same one here. According to law of mass action, at a constant temperature, the rate of reaction is directly proportional to the active mass, the product of active mass of products, mass of reactants, reactants. According to law of mass action, rate of reaction is directly proportional to product of active mass of reactants. See, here rate of forward reaction is directly proportional to the product of active mass of reactants. For forward reaction, these two are the reactants, right? So Rf equals to some constant Kf comes. Kf is the equilibrium constant for forward reaction. B, say equation 1. In the same way for backward reaction, Rb is directly proportional to C into D. Kb C into D. See, you know, at equilibrium state, rate of forward reaction is equals to the rate of backward reaction. Then Kf into concentration of A into concentration of B is equals to this one, Rb value, C by D. Now from this, so Kb comes here when we interchange the terms like this. So Kf by Kb is equals to concentration of C into D divided by concentration of A into B. So Kf by Kb is also called as Kc. Kc means equilibrium constant in terms of molar concentration. So Kc is equals to Kf by Kb, and Kc is defined as, equilibrium constant is defined as the product of active masses of products by product of active mass of reactants. So this is the value of Kc. Here what is active mass? See, for solutions, active mass can be expressed in terms of molar concentrations. But for gaseous reactions or for gases, partial pressure. Active mass is can be expressed in terms of partial pressure. See, active mass is equals to N by V, number of moles by volume in liter. This is the formula for Kc. So what is Kc? What is equilibrium constant? Equilibrium constant is the ratio of product of active mass of products by product of active mass of reactants. Okay, now we will discuss about how the Kc and Kp can be expressed, means expression of Kc and Kp for a given reaction. What are the units, or how do we write the units for Kc and Kp, and what is the relation between Kc and Kp for a given reaction. These three factors we will discuss now. See, first one, expression of Kc and Kp for a given reaction. First one, expression of Kc and Kp for a given reaction. See, say for example, I am writing 2 moles of sulfur dioxide reacts with oxygen to form 2 moles of sulfur dioxide. All are in gaseous form. I am writing Kc value. Kc is equals to, Kc means what? Equilibrium constant in terms of molar concentration. It is usually for gaseous or aqueous solutions Kc can be written. Kp can be written only for gaseous reactions. If it is gas, there will be Kp. If there is no gas, there is no partial pressure. And I am saying another point also, active mass of, the important point is, active mass of solids and pure liquids is 1. Active mass of solids and pure liquids is 1. That means partial pressure of solids and pure liquids also 1. So keep in the mind. Now Kc. Kc is equals to, how can we write is SO3 twice power 2 SO2, it is a reactant, product by reactant P by R, so to the power of 2 O2. It is the expression of Kc. We can write the Kp value like this. Write P first, so write the compound here, and what is the coefficient with that, write in the power, and for the reactants, partial pressure of SO2 whole square into partial pressure of O2. Okay, this is the expression of Kp. This is the expression of Kp. And second one, units of Kc. Units of Kc and Kp. See, Kc, this is molar concentration. No, that's why moles per liter per delta N. So what is delta N? Delta N sometimes written as delta Ng, means number of moles of gaseous products minus number of moles of gaseous reactants. So number of moles of gaseous products minus number of moles of gaseous reactants. For a given reaction, delta N value comes, or calculate, and that one is substitute at delta N place in the units formula, and you get the units for Kc for the given reaction. In the same way, Kp. Kp is equals to partial pressure, no, that's why atmosphere. So delta N. So we will find the units for this reaction. Kc units are moles per liter, right? Moles per liter per delta N. Delta N value is how much? See, for this all are in gaseous state. Number of moles of products are 2 minus number of moles of reactants here, 2 plus 1 3, means minus 1. I substitute minus 1 here. So Kc units are what? Mole per minus 1 and liter. This is the units of Kc for this reaction. Now what are the units of Kp for this reaction? Units of Kp. So Kp is equals to atmosphere per delta N. Delta N value how much? Minus 1. That means atmosphere inverse is the unit for this one. Okay. Now the third one is relation between Kc Kp. Relation between Kc and Kp. See, what is the relation between them is Kp is equals to Kc into RT per delta M. I am taking three cases here. If delta N is 0, if we substitute 0 here, x power 0 always 1. So then what? Kp is equals to Kc. Case 2, if delta N is positive value, if it is 1, then Kc and Kp, which value is bigger? Kp value is bigger. Why? Because when you multiply this term with Kc or by Kc, you get only Kp value. That's why Kc is lower value, Kp has higher value. Kp greater than Kc. If delta N is negative, then if it is negative, minus 1 say for example, Kc divided by RT, right? So Kc value is bigger. When you divide Kc by RT, then only Kp value comes. So Kc value is bigger, Kp value is lower. So Kp less than Kc. So this is a finding process of relation between Kc and Kp. This is very important area. We apply this concept to the above equation. See how much the delta N value for the above reaction. Number of moles of gaseous products minus number of moles of gaseous reactants, right? So gaseous products how many here? 2 minus number of moles of gaseous reactants here, 2 plus 1 3, means minus 1. Kp is equals to Kc RT power minus 1. That means what? This value is negative, Kc by RT, right? So Kp is less than Kc. In this way we establish the relation between Kc and Kp. Now apply the same concept, means expression of Kc Kp, units of Kc Kp and relation between Kc Kp to the another reaction. Second reaction. Second reaction, say for example calcium carbonate in a closed vessel heating, it produces calcium oxide and carbon dioxide, solid. So first expression of Kc Kp. See Kc. See solid, active mass of solids is 1. We cannot express in expression in a given expression. See, solids cannot be written here. So what can we write? Only gaseous term, CO2. So this is the expression of Kc for the above reaction. Kp, how will we write? Partial pressure of CO2. Why? Because partial pressure of solids is also 1. We cannot mention in the expression formula or expression or in representation. So this is one. Second one, units. Kc is equals to moles per liter per delta N. Delta N value is how much? Number of moles of gaseous products 1. It is 0. Number of moles, there is no gases, it is not a gas, so that I am not taking here. There is no gases towards reactant side. So 1 plus 0, 1 minus 0. Delta N value is 1. So it is 1. Moles per liter is the Kc units. Units of Kp. Atmosphere per 1 means atmosphere. Relation. Third one, relation between Kc and Kp. Formula is there, no? Kp is equals to Kc into RT per delta N. Delta N value is 1, positive value. So when it is the positive value, already we discussed at this point, Kp is greater than Kc. Okay. So this is the expression, units and relation between Kc and Kp. And now I will give you a reaction and write the expression, units and relation between Kc and Kp for that reaction in our comment box. Third reaction, try this question. N2 plus 3H2, 2NH3, gases all. So you have to write the expression, units and relation between Kc and Kp in the comment box. So I hope you understand this concept well. Here, what is equilibrium state? What is equilibrium constant? How can we express that one? What are the units for that? And what is the relation between Kc and Kp for a given reaction? So this area is somewhat significant to understand the problems from chemical kinetics, and it is one of the main areas to solve the difficult problems or stepwise problems also. Okay, thank you.